Welcome to the last part of this tutorial about riverine flooding. Now our situation is that we have our shapefile representing the flooding of the river every meter from 1 meter to 9 meter, but as you can see, the resolution of this shapefile is not very good. We have a pixelized polygon of 10 meters pixel, which is not good for a representation for a final product. Therefore, what we are going to do is to improve, to style those files. We can start with float of 1 meter. You type on the processing tool smooth. You get this algorithm under vector geometry called smooth. You open this mask. You choose the input layer float shapefile 1 meter iteration. You can leave 1, but here it is important that you can put 0.5, the maximal value, and you save this file as float 1 meter smooth and you run. You do the same process for 2 meters 0.5 and you save float 2 meter smooth and you run. The same for 3 meters and you run. Save for 4 meters. Same for 5 meters. Same for 6 meter. Same for 7 meter, 8 meter, and finally 9 meter. Now we have created these 9 new smooth vector files. We can group them, float smoothed, and I put it above. Okay. You can see the difference between the smoothed file and the original one. This is the 1 meter smoothed file and this is the original. If you go with zoom in, it looks much better. But we still need to style all those files. We do it on the same way. To style it, just click twice on the layer, go under symbology, click on categorized, then classify, and we keep only the number 1, which represents the water. Click twice on it. We take away the line here and we do it transparent, a little bit for the transparent. Okay, that's it. Okay, that's fine. Now, since we have to do this exercise for many times, it makes sense to save this style as a predefined style. So you click on style, save style, and you choose the name of the style. In this case, I will choose float hazard 3 level. We save. Yes. See, that's the first meter of water. We do the exercise for the second one. Click twice on the float 2 meter smooth. This time click on style and load the default style, which is called float hazard 3 level. Open and load style and apply. Okay, now we have the second meter and so on up to 9 meter. Now we have all our tiles smoothed and nicely shaped. We can zoom in a little bit. We can see the flooding for the first meter, second, third, and so on. Much nicer looking, up to 9 meters. So at this point we can start to develop a nice looking map with the several levels of flooding. But we have to organize the field trip, and in order to assess the right location, we should identify the most flood prone area. By 1 meter we can see that we have just this area that is little bit flooded, but not so much. Maybe here a little bit inside, but the village is not really involved, especially in the northern part of the village. Nothing really happened. The southern part is this part is more affected to flooding, so we might visit this area. Let's see by 5 meter what's happened. Still on this side we don't have a lot, so maybe it is important to assess this area, especially here where we have a harbor. So I take a point of this location so that when I'm in the field I will find this location easily. So I develop a new shapefile, I call it location to assess. It is a point file name. Okay, this location 1 I can assess, and then maybe it is interesting by 9 meter I have here a location that seems to be also flooded, so I can assess also this location and ask local people how situation look like in reality. Location 2, but more interesting maybe is the location on the other side of the river. For example, here we have a big village that is totally flooded. Might be interesting to go there and see if it is really true and how frequent this village is flooded. We see by 9 meter is totally flooded, by 5 meter is not flooded at all, so the village starts to be flooded by 8 meters only, so we might assess this area as well. I call it location 3. Maybe we can put the name. Okay, where else? It's also all this area upstairs is flooded by 8-9 meter, so it might be interesting as well to assess this location and ask local villagers how is the situation. Location 4. And now let's see if this hazard map corresponds a little bit to our Google satellite image. When you check carefully the vegetation and you put a float, you see that this area has a different vegetation than this one. So this looks actually promising, because here we have bigger trees and here we have kind of smaller trees. So it might be realistic, the whole flooding. Here we have it less realistic, but still you can see big forest, so we can imagine that the real flooding extent on rare case is all this area here, but just based on the vegetation. This is one part. Again, we can do the same analysis here. Let's see in the island how it looks like. Yes, definitely here we have flooding. This looks realistic. This looks less realistic. But finally, question is how come that the village of Beto is almost not flooded? This also we can identify through the profile based on our FabDEM. If I take the profile, for example here, with this plugin called Terrain Profile, I add the FabDEM here, and then I drop a profile line here. You can see how big is here the bank. goes from 324 up to 336. So we have more than 10 meters bank. That's why the village of Beto is actually protected. If we check the profile on the other village, we see that the other village is much lower. That's why the water rise, and before flooding the Beto village is going to flood the other village on the other side. So that's also another way to verify your flooding analysis. So what to do next? Now you develop your nice looking flood hazard map. You put your flood hazard map, including the location to visit, these 4 locations in Avenza app, for example. And once you are in the field, you can at least visit those 4 locations, speak with local people and ask them how floodings occurs over the past, and also observe silent witness and try to verify that your hazard map is kind of realistic. Important is that at the very end in your hazard map you are going to have 3 types of flooding every year, so frequent flooding, less frequent flooding, and very rare flooding. That is the base of your preliminary hazard riverine flooding map. Thank you very much for following this tutorial to the end, and see you soon.